So last time we had talked, we were talking about developing the unit circle. So my idea is, or the idea is we're going to construct a circle with radius 1 centered at 0, 0, so that the points on that circle are cosine theta, comma, sine theta. Where I mean that, let's draw the circle first, that's easier for me. So if this is my unit circle, and we have some initial side and some terminal side, this angle here is my theta, so this point is cosine theta, comma, sine theta. Hi, come on in. Oh my goodness. That's for you. Marku, for you. Joe Warsecki, for you. Sebastian, for you. That one's yours there. Sebastian. Selena, this is for you. Ian, this is for you. Luke's, that one is yours. And then Luke Seaman, this is for you. Okay. So, basically this is what the unit circle is. It's a circle that has radius 1. It's centered at the origin, that's the point 0, 0. And the points on that circle are of the form cosine theta, sine theta, where the point is basically where that terminal side of our angle intersects that unit circle. So that's the point that I'm talking about there. So the x-coordinate is my cosine, and the y-coordinate is my sine. Everybody okay with that idea? You proceeded from there using your 45, 45, 90 triangles and 30, 60, 90 triangles. You extended that unit circle out to something that looks like... let me find what I'm looking for. Forgot that I needed to pull this up. Where is mine? Oh dear. I'll just use this one. Maybe here? There we go. Anytime now, computer. Something that looks like this, right? Right, that's fine. I mean, it's still the same thing because they're just. If you notice, look at the x and y coordinates for the 30s and the 60s. What do you notice? They're just opposite, right? So, again, like, you don't need to like memorize them or whatever, but that is the pattern that's going on. Let me just actually drop that in here. Okay, come on, OneNote. Start OneNoting here. Okay. We're frozen, so it's just going to be a minute, I guess. I don't know what's going on. Oh, this will solve it. And you guys talked about how we developed this. Is that correct or no? Okay, so the the idea then was if I have like, so I have my unit circle, and let's say we'll do the 45 here. So this is 1. Well, let's do this. Let's do this. Let me draw this differently for you guys to kind of see where this stuff all connects. So I want to do this, this, and this. So this is 45, 90. So this is, if I ignore the unit circle part, we know that these are x, x, and x square root 2, correct? So I know that if I now embed like an xy axis here and make my unit circle around here where I fix this value now to 1. So x over the square root of 2 is 1. That implies then that the value for x has to be 1 over the square root of 2. Because 1 over the square root of 2 times the square root of 2 is 1. Everybody's okay with that? Just like 1/2 times 2 is 1. So that means this is 1 over the square root of 2, and this is 1 over the square root of 2. Which means that this point then here, we've gone 1 over the square root of 2 over, and then 1 over the square root of 2 up. And that's the same thing as square root 2 over 2, right? Everybody's okay with that idea? So that's how we've kind of constructed or got these values for the unit circles. We've literally just kind of drawn these 30, 60, 90, or 45, 45, 90 triangles, and then kind of embedded them inside the unit circle and used their leg lengths to figure out the x and y coordinates for it. So, again, is it material that you're able to reproduce that? No, not necessarily. Should you, if I give you a blank unit circle, be able to fill things in? Yeah, you should be able to do that, but that's not terribly difficult. So let's say that you wanted to fill this value in. So we're not going to do anything different than we were doing yesterday. So I'm literally just going to draw this. Let me use a different color here. So I have my initial side, terminal side, so 150 degrees. So what I do then is make my triangle. I notice because this is 150 and the whole thing is 180, I know that this angle is 30, which means that this angle here is 60. So I have a 30, 60, 90 triangle. And I know then the side lengths for this is going to be x square root 3, x, 2x. So I can do cosine of 150. Whoa! What did I forget to do, though, before I get going? I have to remember to fix the signs on my side lengths. When I say signs, I mean S-I-G-N-S. I know it gets confusing in trig class when you start talking about sign, the sign on sign. That's okay. That was a joke. You're supposed to laugh. It's okay that you didn't. Yeah, I don't need your pity. So remember that this is quadrant 2. Inside quadrant 2, the x's are negative and the y's are positive. So this value that's going left and right is negative. This value going up and down is positive. So now, to fill in my unit circle, I'm just going to do cosine of 150, which is opposite over hypotenuse. So I have negative 3 over 2. That's my x-coordinate. And my y-coordinate then is sine of 150, which is just opposite over hypotenuse, which is going to be x over 2x, or 1/2. And again, that's how you can fill in the values on the unit circle if you're asked to do that on a test or a quiz. So again, it's just going back to those 30, 60, 90 triangles. Think those things are important? Oh yeah. Oh yeah. Oh yeah. Those are guys you just are going to flat out need to memorize. So just to reinforce this idea, this relationship between the x and y coordinates on the unit circle, I gave you guys this handout that looks kind of like this. And it asks you for like cosine of 45, sine of 45, etc. So to do this, what I'm going to do is I'm going to draw in, say, if we're looking for cosine of 45, I'm going to draw in the 45-degree angle. So starts here with my initial side, and then this point here looks like 45 degrees to me. What do you guys think? Yeah, I thought so too. So there's that. Everybody's okay there? And now, sine or cosine of 45, which coordinate is that? X or Y? Is the x coordinate. So I'm just going to go on this point. Oops. And I'm going to track down. And I'm going to figure out what this point is. Everybody's okay with that? So I noticed that it looks like the thicker gray lines. I know it's hard to see on the projector. If I zoom in a little bit more here, here's the 0.5. This must be 0.6, 0.7, 0.8, 0.9, 1. So it looks like, to me, if I were to approximate this, I would call this like, let's see if I can track down a little bit more accurately. Maybe here is actually where that is. As you guys buy that, it's maybe one grid line over. So I would say this is about 0.71 is my value. If I were going to do sine of 45, which is the next question, I believe. Oops, sorry, guys. The sheet that I just passed out to you. Bye-bye. If I want to do sine of 45, instead of tracking to the x-axis, I'm going to track over to the y-axis. So if I do that, I have, let's see, here's 0.5, 0.6, 0.7, so about 0.71. Is everybody okay how I used this thing to approximate those values? So what I'd like for you guys to do with the remainder of this sheet is I'd like you to use the unit circle to approximate the rest of these values. Try to do your approximation to the hundredths place. So 2 decimal places you should be able to do. Just to get you a little bit more comfortable with like how to kind of use that unit circle. So again, I'll leave this up here. But we'll take, I don't know, take 5 or 10 minutes here and do that before we move on to the next one. Or the next idea, anyways. Who's finished? Show of hands. On the last one. Who still needs another minute or two? Okay. We'll take another minute or two, and then we'll kind of read through these and see how we did. Sound fair? I'm glad you didn't have a choice. That's what we're doing. Ha 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 ha. I don't know. We'll see what else we're able to get through, sort of thing. You know, Julia? I'm trying. It's hard walking in and, like, plopping down in the middle of class where you're not positive what you've done before, what people are good at or not good at. You know? All right. Let's get a show on the road here. For cosine cosine 125, when I did this, I said it was negative 0.57. If you were in the ballpark, I probably would have said close enough. Again, if you're within a couple of hundredths, no big deal. Now, if you called this like 0.67, that's too far off. But if you're negative 0.5, whatever, you know, like probably close enough. And then I got 0.81, 0.25. I got 1 here. That one you should have had exactly. And I got negative 0.76, negative 0.64, 0.9. Well, I just might 90 if I wanted it to 2 decimal places. 0.42, 0.5, and then negative 1 were the values I got when I filled this in. Hopefully you were relatively close to these. Again, if you're a couple hundredths off one way or the other, probably not a big deal. With the exception of sine 90 and sine 270, you should have been dead on with those ones. Why? Yeah, that's labeled even on there, right? Like, sine 90 is here. It's labeled what that point is. Oh, did you not notice? It's not Allison. That's your sister. That's too confusing with 2 A names. That's okay. You should apologize for your name more, though. Sine of 165. So it looks to me like 165 is right about here. Okay with that? So I will just kind of track over, since we're talking about sine, it's a y coordinate. So this is 0.5, this is 0.4, so this is 0.3, so it looks like a little less than that, so maybe like 0.29-ish. So 0.25, 0.29, somewhere around there. You'll buy that there, Abigail? Okay. And then which other one did you say you wanted to look at? 230 looks to me like right here. So if I track that over, I'm here, and I'll zoom in a little. So this is 0.5, 0.6, 0.7, and then 1, 2, 3. So about 0.73 or so. Oops, but it's negative, right? Because it's on the negative side of the y-axis. Okay with that? Yep, so it's mostly just counting, right? Oh, they're probably by 2, aren't they, huh? Yeah. So, there you go. That's what I did. That's why it was why it was a little bit different from what I just wrote there. If those are by 2s, that's 0.76, and now it's dead on. And this one would have been like, that's like 0.28, which is a little bit closer, right? Thank you, Julia. Good catch. You have 1/1,000,000th of an extra credit point for that. There you go. Better make sure I know who it is, Julia, which one. Okay. So the idea here now, what we're going to do is we're going to transition towards talking about graphs of these trig functions. And what we're going to use to generate these graphs are going to be, in fact, the unit circle. So we're going to start our discussion talking just about graphs of sine and cosine. And then we're going to move on to talk about graphs of tangent and cotangent, cosecant, and secant, and all those good guys. But right now, we're just going to focus on sine and cosine. Everybody okay with that idea? Okay? To get an idea of what the graph of sine and cosine looks like, we are going to just be plotting values from the unit circle. So I have my xy axis here, and I've done the, well, you know what? This will probably be easier if I do this. Let me do this. Oops. Yeah, that's fine. Options. No, that's not what I wanted to do. Let's do this in degrees because it'll probably just be a little bit easier for everybody involved. I need to change that option to regular. Okay. So that should be okay there. Let's use this one instead. Bye-bye. Hello. Okay. So what we're going to do is we're going to use points from the unit circle and the angle measures of those points to plot. We'll do sine first. So this graph will be y equals sine. So the values from the unit circle for sine are the y coordinates, right? So what I'm going to plot over here is going to be theta, comma, y coordinate. And maybe I should put instead of x, we'll call that theta. Everybody okay with that idea? So the first point on my unit, or first value on my unit circle is 0, and the y coordinate there is 0. So I'm going to plot the point 0, 0. The next value on my unit circle is 0, and the y coordinate there is a half. So I'm going to plot 30 and then a half, which is probably in that neck of the woods. Everybody still doing okay? And then we'll do 45 and then square root 2 over 2, which is about 0.070, or I'm sorry, 0.707. So that is going to be like here. And then we have 60, and that's 3 pi, or square root 3 over 2, which is like 0.866. Again, how am I getting those numbers? Well, I'm just like typing this into my calculator and getting a decimal approximation. Right? Like, how did I get the 0.866 or whatever? I just typed in my calculator to get a decimal out of it, because plotting square roots as a point, maybe not entirely obvious, right? And then I'm a math teacher, so I have them all memorized on top of it, which is because we're big nerds. And then 90 and 1. So that's to here now. So I move over. So I have 120. And then we have negative a half. Oh, we're doing y coordinates. Help me out here. So that's 0.866. I was like, what's going on here? 707, and then 0.5, and then back to 0. So we have 120, which is probably here. And then we have 135, which is probably in that neck of the woods. Stop it, computer. And then we have 150 is the next one, right? No. Yeah, 150 is the next one, which is here. And then we have 180, which would be there. Everybody so far so good? Okay. So next we'll do 210, and that's negative a half. So maybe like here. And then I have 225 and 707, so that's going to be like there. And then we have 240 and 0.866, which is like here. Come now. And then we have 270 and negative 1, which would be like here. And then we have from there 300 and negative 0.866. And then we have 315 and like 707. And then we have 330 and negative a half, so like maybe there. And then we have 360 and 0. So if I look at my graph, if I connect these points, I'm going to have something like this. Yes, Abigail? With their corresponding angle measure as the x-coordinate, and then the y value is the y-coordinate. Okay with that idea? And remember that we can read this unit circle going backwards, right? So like this is negative 30, negative 45, negative 60, negative 90, etc. going on in that direction, correct? So if I extend my graph in this direction, it's going to look like, so I don't know, like here, 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 here. So it's going to look like something like that, right? Is everybody okay with how I was able to just kind of extend that? Because it's going to do the exact same thing, just in the direction. What are we going to do after 360? We just repeat around again, so you get like another one that looks like this. So we have a special name for this kind of graph. This is called a periodic function, because it repeats after some interval, in this case every 360 degrees. Or if you're thinking in radians, 2 pi radians. Are we out of time? We still have like 5 minutes or something, right? Okay. So let's talk about like domain for this function. Does anybody remember what the domain for a function is? Okay, so the domain is the set of possible inputs for the function, right? That's what the definition of a domain is. These are going to keep going forever in both directions, right? So those of you that said the domain was all real numbers or negative infinity to positive infinity, that's correct. What will the range be? Okay, negative 1 to 1. Notice that I'm using brackets here because negative 1 and positive 1 are both values. So just the biggest y value and the smallest y value, and we're connected all the way in between. Good. The maximum value for this function is, well, 1, right? That's the biggest output for the function, like we have in the range. And the minimum value then is the -1, right? That's just the smallest value in the range. Okay. What will the end behavior be? Did you guys talk about end behavior earlier? No? Then let's not worry about it. If we haven't talked about it, let's not do it now. So a special feature of periodic functions is we want to talk about the period for these functions. And the definition for period is the shortest non-repeating segment of the graph So if I think about my graph here, if I start at any spot, let's say we start here, if I do this much, this is all different until I get to here, and then whatever we do after this is going to be the same thing as I've already done before, right? Does that make sense? So how long did it take me? I started at the value 0 and I ended at the value 360. So we say the period for y equals sine x, we should say theta, is 360, or if you were talking in radians, 2 pi. Another thing that we talk about is the amplitude. Maybe actually before we do that, we should call this we should define something called a mean line. This is a horizontal line that divides the graph in half. So for us up here, the mean line is just going to be the x-axis, right? Because I notice that I have half of the graph that'll be above and another half that'll be below. Everybody okay with that idea? So for sine theta, y equals 0, or the x-axis, is the mean line. And then the last thing I want to talk about is amplitude. And this is the greatest distance the function is from the mean line. So in the case of y equals sine theta, the amplitude is 1. So for sine, the period is 2 pi, the mean line is the x-axis, or y equals 0, and the amplitude is 1. We will... Oh, sure. Yeah, of course. I just get excited sometimes, Julia. So tomorrow we'll talk about just y equals cosine theta, and then start talking about transformations of these and how to do that.
So this is homework that I missed from Thursday.
Okay.
Can I have
The handout? Yeah. You're welcome, sir. Make along the way, and you can, alter things a little bit if you want, or like take things out that you didn't talk about as much, but just to give you a feel for like what it is that I'm doing or whatever.
Yeah, that's what I want to. That's what I told the kids. I want to keep the integrity of what you end up doing. So
yeah.
All right, that sounds like a good idea.
Okay.
Thank you very much.
You're welcome.